Hello, we are going to talk today about acids, bases, and salts and how you easily determine those using the chemistry reference tables. Let's take a look. In fact, we're going to start with salts first. Salts, you already know, is a combination of a metal with your nonmetal, or, of course, a polyatomic ion, which is going to be on the reference table E. In these cases, you have an ionic compound. It has an ionic bond, the transfer of electrons, and it's fairly easy to see. Your most popular, in my opinion, ionic compound is good old sodium chloride, your metal nonmetal. But acids and bases you also need to know, and they happen to have two reference tables here that will help us with identifying an acid or a base. Just like salts, acids, and bases, when they are in solution, you get ions. They will conduct electricity. These are known as electrolytes. So let's check out where we would find those. All right, reference table K are your common acids. And if you don't remember the definition of an acid, it's fairly easy when you're looking here at the formulas what they all have in common. And that happens to be an H. The hydrogen ion in solution tells us that we have an acid, and you'll notice that they all have AQ in parentheses because in water, these ionize, they split apart. Now, we have covalent bonding going on with our acids, but again, in water, water being polar, it's going to go ahead and split up those acids. It's easy to identify an acid by its name because the word acid is in all of them. All right, for bases, here they are down here. Now, with bases, you notice you got a metal in OH for NaOH, KOH, and CaOH2. These are all the metal name with hydroxide, which is a polyatomic. The last one, however, this aqueous ammonia, this does not follow the same trend. However, when you put ammonia in water, you get ammonium hydroxide. Just turns out that the definition of this, ammonia being a base, goes under an alternative theory in acid-base chemistry, um, that this is accepting the H plus and you get the NH4OH. We're not going to really worry about that in this lesson. We'll take a look at that down the road. But anytime you're dealing with an acid or a base or both, when it comes to chemistry Regents questions, you want to go to table K and table L. Now, once again, just like with our salts, acids and bases are electrolytes. Now, with electrolytes, you can have strong electrolytes and you can have weak electrolytes. And then you have also substances that dissolve in water, but they don't conduct electricity at all. All right, as far as what acids are strong and what acids are weak, and what bases are strong and what bases are weak, I tried to indicate that here with my bad handwriting. If you have a strong acid, you have a very good or strong electrolyte, meaning that it readily breaks apart into ions. If it is a weak acid, it still breaks apart, but you're not going to have as strong of an electrolyte. It's not going to conduct electricity as easily. It's known as a weak electrolyte. Same thing with your bases. All of these three metals, sodium, potassium, and calcium and hydroxide, those are all strong. The only one that's weak down here is ammonia. If you're just asked about whether or not they're electrolytes, all of them on these tables are electrolytes. Good old reference table F. These are solubility guidelines for salts in water. And anything that is soluble, that means it's going to be a strong electrolyte. The exceptions here, insoluble, would mean weak electrolyte at best. So our insoluble compounds, which are going to have one or more of these ions combined, are weak or non-electrolytes. Anything that is soluble are going to be strong electrolytes. I'll do a separate video on reference table F. And finally, I want to mention organic compounds. Your organic compounds are your carbon-containing compounds, and most organic compounds are non-electrolytes. The two big ones that we deal with that dissolve in water but don't split apart would be your sugars like sucrose and glucose and your alcohols. Now, we got to be careful with alcohols. So let's take a look at the third organic table. This table, reference table R, is the third organic table on the New York State reference tables. These are carbon compounds that don't just take or bond rather with hydrogen, but would bond with other elements as well. Your group, known as your alcohols here, they are soluble in water but don't break apart. The reason why I'm mentioning this, if we take a look at this 1-propanol example here, you see that OH group. And you might say, wait a minute, under the other reference table for bases, I saw NaOH, KOH, CaOH2, and they're soluble in water and they're breaking apart. Why aren't alcohols breaking apart? Well, you have to look at, of course, the other element or elements that OH is bonded to. In the case of an alcohol, we have our carbons and our hydrogens. In the case of bases, we have a metal NOH. Easily recognizable because of these other elements, totally different properties. Again, any kind of base, you're going to have an electrolyte, it's going to split apart, even if it's insoluble or nearly insoluble, but our alcohols will never break apart in water. I almost forgot one more thing. Your organic acids. These are carbon-based compounds, but you have this C double bond O and OH. And just like the other acids on the other reference table, there's a separation here, and the H will come apart from the rest of the molecule. These ionize. These are all weak electrolytes, but they are electrolytes. Okay, so let's take a look at this worksheet here, and we're taking compounds, their formulas, and we're trying to identify what type of compound we have. If we take a look at number 1, I have to identify that I have calcium, which is a metal, and oxygen, which is a non-metal. If you don't know that, just take a look at the periodic table. A metal and a non-metal form a salt. If I look at the next one, first thing you're going to notice here is you have H in front. Double check with the reference tables. Yes, this is an acid. Now, the next one, number 3, is a little confusing. NH4OH is a base. On the reference tables under bases, remember it's listed as NH3. And that is because when I take ammonia and I dissolve it in water, I get NH4OH. This is not an alcohol. This is a base. You might remember, of course, that NH4 is the poly, the ammonium ion. It is a base. It's going to split apart in water. For number 5, this should look familiar. This is glucose, and this is a sugar. For BaSO4, I have a metal again in barium and SO4 poly. This is going to be a salt. Lithium chloride, metal, non-metal, salt. CH3OH. Oh, now I have carbons and hydrogens and OH. This is an organic compound, better known as an alcohol. For number 9, you might say, oh, wait a minute, organic, but hold on, it's more than that. It's a special organic compound because we have the H in front. Take a look, it's an acid. And then to round this out, C6H12O6 must look familiar to you, and that is, of course, a sugar. For the rest of these, let me clear this out. Let me move on this up. All right, you're looking at 11 through 23. I'd like you to pause the video, figure out what you have, and come on back for the answers. Here are the answers. If you got any wrong, make sure you check out the formula again. And if you have any further questions, you can put them in the comments below. Let's do one more thing. Let's take a look here at a quick worksheet on electrolytes. We're either looking for an electrolyte, be it weak or strong, or a non-electrolyte. What I suggest you do is you read the top here, pause the video, and then we'll go ahead, or I'll go ahead rather, and post the answers 1 through 5 first, and then the rest. While these all dissolve in water, only sodium chloride, which is a salt, and hydrochloric acid, which when you put it in water breaks apart into ions, are your electrolytes. You have an alcohol in number 2, methyl alcohol or methanol. Glycerol is also an alcohol. It just has more OHs. But you notice you have your carbons and hydrogens, not a base. It's an alcohol. It is organic, but it is a non-electrolyte. And then finally, your sugar. Your sugars dissolve in water. They are organic, but they don't break apart into ions. Again, non-electrolytes. Couple more to go, and we're done. All right, 5 through 10. Pause the video, do your checks, and come on back. All right, how'd you do? Your sugar, your alcohol, they are both non-electrolytes. Everything else here are electrolytes. Sodium hydroxide is a base. It's also a salt. It's ionic compound, but it's a base. And then you have acetic acid, your ammonium hydroxide, better known as ammonia and water as well, and your sulfuric acid for number 10, which is an electrolyte. Thanks for watching and keep up the good work.